We're going to look at several different types of functions today. In this case, we have our stepping up coffee house. It sells whole bean coffee. Well, they charge $9 per pound or any fraction thereof. In other words, if it was a half a pound, they'd charge $9. If it was 3/4 of a pound, they'd charge $9. If it was 9/10 of a pound, they'd charge $9. Even if it was 1/10 of a pound, they'd charge $9. If it was 1 pound, they'd charge $9. However, if they got to 1.1 pounds, they would then round that up to 2 and then be $18. So as we start going ahead and plotting some of those points, we said anything between 0 and 1 was basically $9. Even when we did 1, it was $9. However, if we did not have any coffee, we would not have any price. So there'd really be an open circle here. We had said once you would get to, say, 1.1, it was $18. And anything between 1 and 2 gives you $18, including 2. However, right here, there'd be an open circle. And then this pattern would continue. So in other words, you would end up getting a graph that would look like this. Since it's a series of steps, we would refer to this as a step function, hence the name of our stepping up coffee house. Your step function could be written in calculator notation or mathematical notation as follows. Now this is about as close as I could get with the computer. It's technically why this. So it's really a square bracket with a vertical line in that bracket. So it's really y is equal to that. Which means you're going to take whatever you have in your parentheses and round it before to an integer before you go ahead and multiply it by the 9. So for this particular function, you're going to go ahead and look at your domain. Well, your domain's anything you put in. So for your stepping up coffee house, you could have any positive number being your domain, meaning how many pounds of beans you're going to sell. You can't sell 0 pounds, you can't sell a negative, so we're not going to have a negative. And so we know it's just positive. When you look at anything you get out like 9 and 18 and 27 and 36. You don't get out the numbers in between them. So you can't just say greater than 9 because that would also include 10, and there's nothing here at a height of 10. So your range is just this. Well, another way to say that is that it's really just any multiple of 9 where, so you could write 9 times n, where n is a natural number. When you're dealing with this step function stuff, it really takes whatever's in your brackets and rounds it down. Here we have Constant Pizza Castle. Charges $3 for delivery, no matter where you live. So if you live a half mile away, it's $3. If you live 2 miles away, it's $3. If you live 10 miles away, it's $3. So when you graph this, you end up getting basically just a horizontal line. But there's an open circle right here, because if they're not delivering, and that would be a distance of 0, there's no charge. So it's called a constant function because it doesn't go up, doesn't go down, it doesn't change. It's always the same value, hence it's a constant function. In this case, our domain is going to be all numbers greater than 0 in the context of our problem. Our range is what we get out. In this case, we only get out 3. We don't get out any other numbers. Oops, wrong button, sorry about that. Here we're going to go ahead and take a look at y is equal to the absolute value of 3, or x. The shape of any absolute value graph is always the shape of a V. Since it's not a line, we're going to just make a t-chart and choose numbers on each side of 0. When you do that and plug negative 3 in, makes it positive and so on, you get these values. When you plot those values on your number or chart over here, you end up getting a V shape. The domain of your absolute value is always all real numbers. Your range here is what you get out. Notice you never get out any negatives. We get out a 0 and we get out positives. And so your range is greater than or equal to 0. Now, if you go ahead and graph this on your graphing calculator, you'll notice your domain doesn't change, but that plus 3 really just moves it 3 units up, so your range is greater than or equal to 3. Here, your minus 5 really just moves it down 5 units, so it's still a shape of a V, so it's all real numbers, but it's just y is greater than or equal to negative 5, because it starts at negative 5 and goes up forever. Let's go ahead and take a look at a piecewise function. Your absolute value could be written as a piecewise function. You notice we had y equals x for this part right here. This line is just y equals x with a y-intercept of 0. This one here is just y equals negative x. And so it's y equals x when you're dealing with numbers to the right of the y-axis, x being greater than or equal to 0, and y equals negative x when you're dealing with numbers to the left of the y-axis, or x being a negative number. And so if you take a negative number in, you know you got to take the opposite of that. So let's go ahead and graph this piecewise function. These are called piecewise because we have two different pieces depending upon the values of x. This one here says you always get out a negative 3 if you put in something to the left of a negative 1. Well, here's to the left of negative 1 of negative 2, says you get out a negative 3. Here, you're to the left negative 4, that says you always get out negative 3. So no matter where you go when you're to the left of your negative 1, you always get out a negative 3. Even if you put in a negative 1, you're going to get out negative 3, but since there's no equal to here, it's got to be an open circle. So graphing the bottom part, we get this down here. Let's go ahead and graph this part here. Now here it says you've got to choose any value from negative 1 and to the right. Well, if you try negative 1, plugging it in here, you get this. Try 0, plugging it in here, and you get this. Try 1, because 1's to the right of negative 1, plug it in here, and you get this. So in other words, when you graph all those points for that top function, you will get this here. Typically, a piecewise function will be at least two different pieces. We have two totally separate graphs, so it has to be represented by two totally different pieces here. In other words, this is your rule. It tells you what to graph. This tells you when to use that.